Okay.
All right. Wow. Well, thanks, Trevor. We might move on to the last talk now for the day. And oh, look, Greg's got a question as well, but we'll come back at the chat, okay? Because we're now running minutely over time. So Damien Lefebvre from Cronimet is going to tell us all about Mount Carbine and the fantastic things that you guys are doing there.
Yeah, thanks, Helen. So I think I share now my screen with you. So it will be a slightly different presentation than my colleagues before, because we are above ground now. But I will talk about the current activities on site, which are around two main activities. One is a project that we are developing with the support of METS Ignited around an X-ray sorter to look at the historical tungsten mine waste. And the second approach is a revisitation of the geological approach for the Mount Carbine tungsten. So Mount Carbine I mean, location has been presented by the other Damien earlier. So tungsten was discovered there in 1895. It has been in operation in the 70s and 80s, at which time it was representing 40% of the Australian annual tungsten production. Current resources have been estimated in the hard rock, so underground part, still about 47 million tons at 0.13% WO3. We'll see in the last slides that we are revisiting that a fair bit. But we are also looking at a low-grade stockpile, which was basically the material taking out of the ground, and looking here at 12 million tons, about 0.07% WO3, and lastly a tailings dam consisting of about 2 million tons at 0.1% WO3. There have been a lot of activities in the last few years on site. The first one of which is the recommissioning of a tailings retreatment plant, a gravity plant, that was put back into production early 2020. So this plant was first commissioned back in the early 2010s, but it was never really efficient. So Cronimet came partnering with Specialty Metals, and we changed a fair bit of the plant, targeting different product there, so production is now ongoing and well. But the second main target, and that's where the work is currently ongoing, is the low-grade stockpile. That stockpile is I mean, of low grade, and has never been considered as directly viable for mining. However, the recent progress in ore sorting, etc., would make it a very sweet target for us. In general, what we see as a trend in the industry is that people are looking more and more at historic mine waste as a new source of raw material. The reason being that it has already been dug out of the ground, so it's readily available. And second is that being a waste, it is also considered as a kind of a recycling. So it is also making very much sense from an environmental point of view. So however, this economic rehabilitation, if we can call it this way, is quite complex and obviously requires site-specific mine waste management solutions. And why is that? It's also mostly because this mine waste materials are inherently complex. That is due to the geological viability, to the grade heterogeneity, and which are always significant obstacles for the sampling and testing and characterization. So our main aim around the Sorter project is to basically develop a geometallurgical approach which will allow us to characterize this material and to evaluate and quantify the resource potential, because it's not only about tons and grades. So for tungsten itself, I mean, tungsten is seen as an industry critical and strategic metal. That is the case in Australia, but that's the case also in most Western countries. It is classified as critical in the US. It is classified as critical in Europe. So and 80% of it is coming from China. So that's really something which is today a target, and obviously it is also a metal that has no substitute today due to its strengths and characteristics. So for the site specificity, so we are looking now at a pilot operation, so which will allow us to really path through volume and look at the proof of economic viability, for that mine waste retreatment, and this is allowed by the recent advancement in the sensor-based particle and sorting technologies, and as well as new way of approaching also the material handling, which is when you look at those low grade minerals, obviously requires a lot of material handling and therefore associated costs. So when it comes to the specific projects, so we are looking here at a partnership, because we realize that while specialty metals had a very good knowledge of their deposits, Cronimet, we have a very good knowledge about how to process these minerals, but we still realize that other people in our respective networks were also having specific knowledge which was of value for the project. And that's where we decided to work with TOMRA Sorting Solutions, DS Mining, which is a bit of a boutique engineering company, and the University of Queensland and its Sustainable Minerals Institute, under the patronage of the METS Ignited program, which are granting us funds also to support this project. And we are all driven by a same aim, which is, I mean, looking at resource efficiency, which is looking at a sustainable resource management by targeting the waste, looking at research and development, both for the technologies, but also for the way we approach the deposit. Advanced technologies, I mentioned, and grain mining, in a sense that we are looking at minimizing our environmental footprint. So who we are, I mean, Cronimet Australia is part of the German Cronimet group. Sorry, we are a global leading metal recycler and trader. So in Australia specifically, we are a project development, investment and service company with our global expertise in mining, waste processing and metal recycling. And we are obviously, being a trader, we are directly marketing our metal product globally to our end users. Specialty Metals, SCI, is the mining leaseholder. It has also a couple of other gold tenements in New South Wales, and we are very happy to work together on these projects. And then we have our key partners. So as I mentioned in the previous slide, TOMRA is a global leader in sorting solutions. And Cronimet has worked for the last couple of years, hands in hands, I would say, with TOMRA. And what is really important is that they have been advancing their technologies to really support our specific requirements. Obviously, each deposit is different, and it requires a specific approach. And it is not the one machine suits all. So it has been really a valuable support. Then the University of Queensland and the Sustainable Minerals Institute, obviously well known to all of you, being a globally recognized research and teaching center with that specific knowledge-based solutions for the sustainability challenges. Yeah. So plus the access to their world-class analytical facilities for all what is mineralogical and chemical characterization, which we will see is a very important part of the project. And lastly, DS Mining Solutions. So they are a little bit of a, yeah, as I mentioned, a boutique consultancy and service company. And with that comes the flexibility and the willingness to look a little bit out of the box. And while doing the evaluation, planning, facilitation of all the mining plans and ultimately the material handling concept. So they are looking really at that innovative solutions, and that's something which for us is extremely valuable. So it is a multidisciplinary approach, and it is especially an iterative approach. So it comes first with the site geological and geometallurgical characterization, but as we said, working on a stockpile, it is bringing, let's say, different challenges than when you look at deposits in ground. Yeah. So the second step is then the installation and the upgrade of that X-ray ore sorter from Tomra, which then allow us to go into the step 3, where we identify the mineralogical and textural drivers for that ore sorting. And obviously, because cost and economic modeling is always of importance, it allows us to basically model all of that. So it really goes from a deep research on the resource definition, looking around the ore sorting on how to exploit this resource, and then how to make that even more economically attractive. So on that first step, I mean, we are looking at a review of the deposit physiology. So again, having been known for such a long time, the ore deposit model is existing. You have a quite good understanding of the ore stroke and alteration mineralogy. You have good understanding of the characteristic in terms of mineralization and the multi-scale ore and gangue characteristics. But what was important, because again we are at first focusing on that stockpile, is to review what has been done there and what information can we work on to basically also help us progress faster in our work. So and that is through a review of the existing trenching and grab samples, and the historical information also on the stockpile origin itself, because the mine has been in operation for nearly 20 years, and the production process has been varying along those years. So if we can link some of the stockpile with information available on processes, etc., then we can get a better understanding of what we might find there. And all of that is then bringing us to a sampling requirement definition for the ore sorting pilot campaigns. First idea that we took out of that is that to be, I mean, of a sufficient scale, we shall consider at least 1,000-ton batch sample, which would allow us to feed the sorter plant for about 10 to 12 hours. And then we also realized that we have two different approaches which will help us to characterize the stockpile and plan our activities accordingly, which is, first one consists of working on composite samples. So grabbing a couple of 100 tons on several different locations. That will give us an understanding of the general behavior, and then looking at localized samples, which will allow us to look at the viability of the stock within the stockpile. Yeah. So TOMRA sorter that was installed on site is a 45 ton per hour pilot sorter, which has been recommissioned for the sorter itself and the surrounding equipment, and which has been upgraded also to Australian standard, because that was an equipment which Cronimet we have utilized overseas. So we have upgraded it to the latest technology with a new sensor put in place for an optimized sorting. We have also reworked the algorithms to maximize recovery and upgrade of the tungsten based on the Mount Carbine specificities. That specific work on the programming on the algorithm will continue alongside the 9 months that the project will last, because depending also, and that's the last parameter, depending on how we feed the sorter, we will ask we will adapt the program to basically maximize the product and recovery. So because the obviously it is directly linked to the mineral characteristic, so crushing and size fraction will be an important parameter, and that will lead also to a maximum feed flow rate, which we will have to validate. Some first results. So we have tested, I mean, we have besides the main low grade stockpile, we have also another stockpile, which is an optical ore sorter reject stockpile. And that came from the historical operation where the previous owners of the mine, they were actually quite technology driven as well, and they had installed an optical ore sorter on site. I think it was the first one in Australia. They utilize it because the wolframite which they were targeting was mostly on quartz veins. So it was a beautiful black on white sorting. But even in that specific reject stockpile, we have been able to recover good material. So what we did, we did the first set of preliminary tests with different size range, 25 millimeter to 50 millimeter, which is for us considered coarse, and then 10 to 25 millimeters. We implemented a high recovery algorithm, and we see that we had in our feed about 0.1% or less tungsten or WO3, and we were able to attain grades of 1.5 to 2% WO3. So that was really promising. It's about 20 times, sorry, upgrade, and that means that much less material to handle. But how are we utilizing that sorter also to do the characterization work around it? We basically decided with our partners from the University of Queensland to use it as a tool to do the sampling. So we pass the 1,000 ton batch through the sorter, and then we do the sampling only on the reject, accept, and undersized material. And then we do all the characterization work, and we build back the feed characteristic. And that is basically allowing us to have a more representative, because it's always difficult to sample such large quantities, but through that it's allowing us an easier, sampling with samples taken every hour or something, and building up basically representative samples. And these samples are then sent to the SMI for further characterization work, with looking at liberation, which is very important. That is basically allowing us then to define which size fraction we shall target for the sorter feed, and then looking also at MLA and tomography when as an ultimate tool to characterize our material. And lastly, looking with DS mining solutions at what kind of solution can we implement when we have gained the knowledge on that stockpile. How do we dig it out, and looking at whether autonomous vehicles will do, whether electrical vehicles shall be considered, and then feeding all that in the Comet software, for financial modeling. So that's really how we are tackling things. What we expect out of it, I mean, we are developing our experience on that, training local workforce, working with potential students also in the University of Queensland, improving our cost competitiveness. That's also extremely important for us, obviously, and transferring experience in other projects. Damien, Damien also, I mean, mentioned the numerous tungsten projects in the area. Obviously, all of them are some targets where such solution could be implemented. We are looking at increasing the production to large scale with over 30 employees. We are also aligning ourselves with the priorities of the Australian government for the critical mineral sector and the development of the METS industry, while also working at lowering our environmental footprint, because utilizing the X-ray sorter, we are minimizing basically the material that we are feeding in our in specialty metals beneficiation plants, so reducing by that much the power, fuel, and water consumption. Yeah, so that's a solution which will be then well suited for the Australian global market, and we would like to utilize it as a kind of a blueprint to encourage investors and other stakeholders to consider this kind of historical mine waste. Which also for us as Cronimet or specialty metals would allow us to look at further investment with potential regional tungsten clusters, as I mentioned, while also strengthening the MET sector branding and recognition. And I would like to also give you a little bit of a view, it's only 2 slides there, on what is ongoing in parallel as a geological review. So it was a review of historical drill holes, so it's 43 of them are available. A recent work showed that the deposit consists of at least 30 veins, which were identified through 154 intercepts, including the 5 major veins which were chased by the historical miners. And how they did it in the past is they were basically following these major veins in the open pit with a large volume of material mined, optical ore sorting, as I mentioned, and they were targeting the same approach for the underground development. We are looking at that with new eyes, and we realize that basically most of the mineralization is contained in this king vein, and pretty much nothing else on the side. So we are looking today at a new approach, which is a narrow, high-grade mine, targeting only these veins, which would once more lead to a higher grade in less tonnage. So again, same approach then for the sorter, reducing basically what we mine to be also more environmentally efficient. And so, as you see on the above diagram, there was an existing 430-meter decline which was dug out just before the mine closed. The people were targeting to basically go underground, go below the open pit, and do the mining. So today we are working with the Department of Natural Resources, Mine and Energy to get access back to that tunnel and, let's say, validate our work on those King's vein. Sorry. And sorry, I would like just to finish with a short video showing you also what the sorter is doing. So in terms of volume split. So if you allow me 2 more minutes, then we look at the presentation. So it's work done on our material in the Tomra Center in Sydney. Yeah. So you see here on the right the product, and on the left the waste. Now the opposite. But you really see the advantage of sorting the material, in a sense that all what is here now being bagged is material that will not have to be further crushed, whereas you will do spending the fine crushing to go in the beneficiation plant only on that tiny portion of material. And if you look on the UV light, so what is shining there is the scheelite, so which is one of the 2 tungsten bearing minerals. And really you see how rich now the feed for the beneficiation plant is compared to the original rock. So that's about it for my presentation.
Thanks. Thanks, Damien. That was fantastic. I didn't actually know that scheelite glows under UV light. I've only ever looked for zircons with it. No, awesome.
That's you shine it now. I mean, all the roads in far north Queensland are shining blue because a lot of it is coming from the quarry actually of Mount Carbine.
Yeah, yeah. Oh, fantastic. Well, that was great. And I have one question. When do you start full production?
Well, I mean, production is ongoing. The matter will be really to ramp up the feed from the sorter operation, because that will really give a boost to the beneficiation plant operation. Because obviously, instead of feeding it with only 0.1% tungsten bearing material, we will have a boost with up to 2-3% tungsten. So then you ramp up throughput. That's really the target. But that's happening in the coming months.
Yeah,
we are working on it.
Great. All right. We've got some compliments on the video from Gavin Red.
He's the one who shoot it, so I return the compliment.
That explains that one. Artem Golev is asking, what about reuse of the rejects from the X-ray sorting as construction material? E.g.,
yes, that's
located at the same site.
Yeah, that's absolutely the case. I mean, the chance that Specialty Metals has is that they are also the owner of the quarry aggregate material on the site. So obviously this material, which is a perfect sized material for the quarry, is returned to them and will be ultimately valued as well. So that's also, it's a double, let's say, double environmental benefit there. It's on one side, we minimize our energy consumption by reducing the amount of crushing required, etc. And on the other side, we are also having no waste, because the supposedly waste is recycled as quarry material. So
and you are mining the waste in the first place. So you're reducing that environmental footprint too.
Absolutely.
Yeah,
yes.
It's a great story. And Kim Cavallaro says, fantastic, Damien, you've done us proud. So
she said that those are the partners of Specialty Metals. So thanks for that. That's, again, I think that's something which we highlighted is, and that's also a general environment in Queensland. I felt, not being a Queenslander myself at all, but it's that collaboration environment which is really making this project successful. So all very glad to collaborate there.
Agreed.
Damien, do you see any potential issues with the scaling up from the sort of pilot scale production to full scale production in terms of the sorter, or it's basically the same machine, isn't it?
It's the same machine. I would say it's a wider machine. I mean, it's the width of the belt which is limiting you, because you need to have only that one layer of rocks to be basically able to be selective. So the larger the belt is, the larger your throughput is. So that's just basically the exercise. And when you reach probably the maximum size, which is today about 2 meters, then you multiply the number of machines, in a sense.
And is there a have you got a good handle on the sort of variability of the stockpile, or is the variability low enough so that you don't really need to worry about that? Or
well, I mean, at the moment, that's exactly what we are trying to look at, because we know in this 12 million tons, for instance, I think it's about 4 million tons are wrong blasts. So it was potentially run of mine material. Yeah. So and that would be carrying a higher grade. But what we have seen also by testing several stockpiles available from this the lowest grade on the optical ore sorter to the low grade stockpile, and my colleagues have been testing lately some run of mine material that is also available. They see that the sorter is basically doing its job exactly the same. You just increase your throughput. The more material you feed in, the more you recover, or the more tungsten units you feed in, the more you recover. But we are looking at seeing whether there is an interest maybe in blending lower grade area and higher grade. But at the moment, it just looks incredibly, let's say, resilient to those variations.
And if I read that table correctly, there were some spectacular upgrades in
Yes.
material that had already been through the optical sorter.
Yeah, and the main reason, as I said, the optical ore sorter was really targeting wolframite over quartz, the black on white sorting. But a lot of the tungsten bearing mineral there is scheelite, and that would be white on white. So they would have missed that. Whereas the X-ray is basically working on the difference of molecular weight. So then you don't miss it no more. You just look really in and you get that, you recover that without a problem.
Mm-hmm. Great, thanks.
Awesome. Well,
oh, there's one from Greg Morse.
There's one from Greg. How much wolframite is there compared to scheelite? Because at Wolfram Camp, they had trouble recovering the wolframite because it was brittle.
Yeah, that's I mean, scheelite is in a sense equally brittle, but in the historical mine, they always considered they had about 80% wolframite, 20% scheelite, which is a little bit the opposite in the tailings, because the wolframite has been recovered, the scheelite is left. In the low-grade stockpile, the ratio is still very much the same, but the luck we have in Mount Carbine is that material is quite coarse. So if we don't go through over crush, we don't have the problem of not being able to recover it. And that's really what the sorter is helping us at, because by already doing that pre-upgrade, we don't have to go into very fine crushing to liberate everything. We just, do that last bit of work on that already enriched material.